Hello. I'm here today to talk to you about the odds ratio and explain how it is used as a measure of association between exposure and outcome, and how it's particularly useful in case control studies where the relative risk cannot be calculated. I'm going to illustrate that statement by backing up a bit and going through the following concepts: measures of chance, odds and probabilities, odds ratio versus relative risk, interpreting the odds ratio and relative risk, odds ratio and relative risk in cohort studies, odds ratio in case control studies, followed by a summary. So, the first thing we need to do is understand the difference between odds and probability or risk. Essentially, both odds and probabilities are ways of expressing chance. For example, let's take the question, what are the chances of drawing an ace out of a deck of cards? The way we most often answer this is in terms of probability. Chances of drawing an ace, 4, out of the total chances, 52 cards, is 7.7%. We can also answer this in terms of odds. Chances for versus chance against. In this case, the odds are 4 to 48, or 4 aces to 48 non-aces. Odds and probability, or risk, are just two ways of explaining the same thing. It's also good to note that you can calculate the odds if you're given the probability and vice versa. Okay, so now we know that the odds and the risk are both measures of chance. Let's look at how we can use them to calculate two different measures of association: relative risk and the odds ratio. So let's start with the relative risk. The relative risk looks at the probability of the event occurring in one group to the probability of occurring in a second group. Let's look at this example of smokers and CHD. Of our 300 smokers, 84 developed CHD, which is a probability of 2.8%. Of the 500 non-smokers, 87 developed CHD, which is 1.7%. When we divide the risk for smokers by the risk for non-smokers, we get a relative risk of 1.61, meaning that smokers are 1.61 times more likely to develop CHD than non-smokers. The odds ratio compares the odds between both groups. We take the odds of smokers developing CHD and divide it by the odds of non-smokers developing CHD. This gives us an odds ratio of 1.62. So both the relative risk and the odds ratio are measures of association that compare the likelihood of an event between two groups. Now, what do these numbers actually mean? When the odds ratio and the relative risk equal 1, this means that the event is equally likely in both groups. In other words, there's no association between the exposure and the outcome. When it's greater than 1, it indicates a positive relationship between the exposure and the outcome. When it's less than 1, this suggests a negative relationship between the exposure and outcome. Perhaps the exposure has protective qualities. Now, I want to talk about how we apply these measures of association to different study designs. On the left, you'll see our previous example, which happens to be a cohort study. In cohort studies, we start with exposure, smoker, non-smoker, and follow them to see who develops the disease, CHD. In cohort studies, both the odds ratio and the relative risk are useful and reliable measures of association. For the relative risk, we ask, what is the probability that the disease will develop in an exposed person? And for the odds ratio, we ask, what are the odds that the disease will develop in an exposed person? Now you'll have to notice that both the relative risk and odds ratio are very similar. This is because the disease incidence in our hypothetical population here is very low, around 3.42%. When disease incidence is rare, less than 10%, we can use the odds ratio to estimate the relative risk. Let's take a look at what might happen to our relative risk and odds ratio if the disease incidence was higher. In this example, you'll notice that I've played with our data so that the CHD is much more common. The incidence in our study population is now up to 43%. The relative risk is the same, but the odds ratio jumps way up. Now, the odds ratio is still an accurate measure of association, but it's not a valid estimate of the relative risk. On the right, you'll see a case control study, which starts with cases and controls and looks backwards for a history of exposure. We can't directly calculate the relative risk here because the relative risk relies on incidence data. Recall that relative risk asks the question of those who are exposed, how many develop the disease? We don't have the data we need, but we can still calculate the odds ratio and estimate the relative risk by asking, what are the odds that this case was exposed? Notice that the equation looks a little different. We're taking A to C versus B to D, but thanks to the cross multiplication rule, our answer is still the same. Since we know that the incidence of this disease is relatively low, we can assume that the odds ratio is a reliable estimate of the relative risk. In summary, odds and probabilities, or risk, are both measures of chance. The odds ratio and the relative risk are measures of association that compare the likelihood of an event between two groups. Both the OR and the RR can be used in cohort studies. Only odds ratio should be used in case controls. The odds ratio can be used as an estimate of relative risk when the outcome of interest is rare. Thank you.